What do Teslas, iPhones, and watches all have in common? They all run on batteries. Batteries are sources of energy consisting of one or more electrochemical cells that transform chemical energy to electrical energy. Though Benjamin Franklin first coined the term battery in 1749, it wasn't until Italian physicist and chemist Alessandro Volta that the battery was invented. After a series of electrochemical experiments, he was able to build a simple battery by about 1800. This battery consisted of alternating zinc and silver discs, separated by layers of cloth soaked in a solution of sodium hydroxide. Batteries contain electrolytes, acids or salts, that allow an electric charge to pass through. When connected to an external device, like a light bulb for example, an imbalance is created in the battery that drives electrons to the positive end, the cathode, of the battery. Cells utilize redox reactions in order to create this transfer of electrons. In redox reactions, one element is oxidized, it loses an electron, and another element is reduced, it gains the electron. The substances oxidized at the anode and reduced at the cathode determine the voltage and the usability of the battery. Here we have the half reactions of a sample lithium-ion battery. At the anode, the lithium cobalt oxide is oxidized, and the result is cobalt oxide, a lithium ion, and an electron. At the cathode, the lithium ion plus 6 carbon atoms and an electron result in LiC6. This reaction proceeds spontaneously because it is thermodynamically favored. Batteries are either primary or secondary cells. Primary cells cannot be recharged and are discarded after the reactions stop, and their voltage becomes zero. Examples include zinc carbon cells. Secondary cells can be recharged via an external energy source. Examples include car batteries. Let's take a closer look at lithium-ion batteries, our topic for today. As the name suggests, these batteries use lithium ions to create electrical energy. A lithium-ion battery has several key components. The anode stores the lithium and is typically made from a carbon substance like graphite. The cathode also stores the lithium and is made from a chemical compound that is a metal oxide like lithium cobalt oxide, LiCoO2. The separator blocks the flow of electrons inside the battery but allows for ions to pass through. The electrolyte liquid sits between the two electrodes. It carries the positively charged lithium ions from the anode to the cathode and vice versa, depending on whether the battery is charging or discharging. Here are the lithium-ion battery components. Okay, battery function. While the battery is discharging and providing an electric current, the anode releases lithium ions to the cathode. The movement of the lithium ions creates free electrons in the anode, which creates a charge at the positive current collector. The electrical current then flows from the current collector through a device being powered, like a cell phone or a computer, to the negative current collector. The separator blocks the flow of electrons inside the battery. When the battery is charging, the opposite happens. Lithium ions are released by the cathode and received by the anode. Let's take a look at an animation that shows just how a lithium-ion battery works. Okay, so here during the discharge, you have the lithium ions moving from the anode to the cathode. And here during charging, you have the lithium ions doing the exact opposite. They're moving from the cathode to the anode. Okay. Why are lithium-ion batteries used? Lithium-ion batteries achieve a greater specific energy density, which is the amount of energy per unit mass, than other nickel-based batteries because lithium ions are very light. Lithium-ion batteries produce a higher voltage per cell, 3.7 volts per cell, compared to 1.3 volts per cell in nickel-cadmium cells. In conclusion, batteries turn chemical energy into electrical energy. Cells utilize redox reactions in order to create this transfer of electrons. In redox reactions, one element is oxidized, it loses an electron, and another element is reduced, it gains an electron. Lithium ions are used in a number of portable devices. Lithium-ion batteries consist of an anode, where a substance is oxidized, and a cathode, where a substance is reduced, a separator that blocks the movement of electrons within the cell, and an electrolyte that allows ions to move from one end to another. Lithium-ion batteries produce a greater amount of energy per unit of mass than other nickel-based batteries because lithium ions are very light. Lithium ions are able to produce 3 times as many volts as an average nickel-cadmium cell. Lithium-ion batteries are rechargeable and are considered secondary cells. Thank you all so much for listening. I hope you learned something new.